Hello, Sam fans, and welcome to this Sam Science Physics edition of Life and Death of a Star. This is triple content only, so if you are not doing triple content, then please do look at my other videos, which can no doubt help you in your life in science. That's on my YouTube channel. If you are doing triple content for AQA or Edexcel, then you need to stay on this video because it could change your life. In fact, it will change your life and save your life. Okay, so before we begin, stars be like fission, no, fusion. Of course it is. If you didn't know that before, then you definitely need to stay on this video. So stars go through a process called nuclear fusion, which you should have covered already. If you didn't know that, then you need some serious help. We need to go through this now, and you need to make sure that you replay this video and watch it again so you understand. So let's start. So what I've done is I thought I would just break down the different steps into stages and titles just to help you remember it easy. So to begin with, clouds and dust are formed, and these are called nebula. So stars, if you didn't know, are formed from dust and gas, and that's just called nebula. Nice and simple. Awesome. Okay, then what happens is that the force of gravity pulls that dust and gas together. What then happens is temperature rises and the actual prostar itself becomes denser. So what that means is it becomes heavier. This leads to, of course, something called nuclear fusion, which gives out lots and lots of energy. Now, if you forgot what nuclear fusion is, it's basically atoms, different atoms coming together, sort of colliding, bashing against each other, which then create a new atom, and that within itself produces lots of energy. So it's basically the opposite of fission. Okay, so because of this phenomenon that happens, what then eventually happens to the temperature is that it rises and becomes very hot. This is called a prostar, and this is the moment that the star itself is born. Okay. Then the next stage is something called a main sequence star. So what happens during this point is that there's outward pressure from the fusion itself. So that phenomenon of fusion taking place, lots of pressure is created, and this makes the star itself expand. Okay, and it needs to balance the gravity between inside and outside, which then happens there is that everything is then pulled inwards towards the star itself because an unbalance at the moment. What the star tries to do because of the pressure is try and balance itself, and eventually everything is pulled inwards. Okay, now there's two pathways that can then happen after the main sequence stars. So it could either turn into a red giant or a super red giant. So let's have a look at if it was to go through the red giant pathway first. So if the star itself, the prostar, if you like, itself is the same size as the sun, okay, what then happens, it turns into a red giant. Now, this is when hydrogen in the star runs out and it begins to swell. So it begins to get bigger, essentially. Okay, and this then becomes red and cools down. And this is because it turns red because the surface is beginning to cool down itself. Okay, and this only happens, remember, if it's a small star. So it's the same star, same size as the sun itself. So the fusion of the helium and other elements, of course, takes place and occurs within the red giant itself. And iron is also created in the core of the star itself. Okay. The next path of that is that it turns into a white dwarf and eventually a black dwarf. So what then happens, bearing in mind, remember, we're still on that small to medium-sized star, so no bigger than the sun, that then itself becomes unstable and starts to spew out and eject gas and dust. And this is the outer layer. And that's what makes the white dwarf bright. It's because it's got dust and gas and it's spewing it out of itself into space. That's why it shines so brightly. And then what's left behind is a very hot, dense, so heavy, solid. That's what's left behind after it ejects out the dust and gas. When it cools down, it then turns black, and that's what we call a black dwarf. It cools down and then gives off less energy. That's why the black dwarf itself is black, and it's not actually white at this stage. So it turns white first, then turns black afterwards. Okay, so let's have a look at the other end. Now, if the star itself is much bigger than the sun, we call that a red supergiant. So what happens during this red supergiant is that the big stars, because it's obviously bigger than the sun, they begin to glow very bright. So more fusion takes place and the star itself begins to expand and contract. So what that means is it begins to pulse. So it sort of goes inwards and then relaxes, it contracts and expands and gets bigger. It's very similar to like a beating heart. if you think it contracts and relaxes, it's a little bit like that. And eventually they then explode within themselves, and they explode into something called a supernova. And this ejects and spews out elements which are heavier than iron itself. Okay, and these bits that sort of come off and spew out into the space then forms new stars and new planets. Now, when it forms new stars, the whole sort of process then takes place again. Okay, and the elements that are spewed out themselves, they're different elements, but they are much more heavy and denser than iron itself. Okay. And then finally, of course, the next process it takes is it turns into a neutron star, or it can turn into a black hole. So the exploding supernova again starts to spew out and chuck out lots of dust and gas into space. What's left behind is very, very dense, so very heavy core, and that heavy core is called a neutron star. Okay, now if the star is massive enough, what will then happen is it will become something called a black hole. Now this black hole is a super dense, so very, very heavy point in space that not even light or gravity can escape from. Okay, so it's probably the most powerful phenomenon that we know in existence in science at the moment. Okay, gosh, you're such a star, you know, going through all them stages of life and death of a star. What was that about? I thought this was quite interesting. A day on Jupiter's moon lasts less than 5 hours. Time must really fly on Jupiter. It's very, very similar to Saturday, isn't it? And Sunday on Earth, especially that Sunday where it feels like it's just an hour on Sunday. Okay, so we've gone through the stages of a life and death of a star. What I've done is I've condensed it into these subheadings, which should help you. Now, seeing this as a 4 to 6 mark question in exams, it's probably a killer actually, and it really throws off students. So what I found was that if you were to remember the headings of each stage, the other parts of the description should come afterwards, because you've got a bit of a jog of the memory there. So it goes anti-clockwise. So remember, it starts off with cloud of dust and gas, then turns into Prostar because of the gravity, then turns into a sequence star itself. Then, if the star itself is smaller than the sun, or around about the same size, it turns to a red giant, which then, of course, turns into a supernova, if you remember. However, if then the star itself is bigger than the sun, it's turned into something called a red supergiant, and then what's formed is a neutron star, or it goes down that dark side and turns into a black hole, and again, you know, is able to suck in everything that's within existence there. Thank you very much, Sam fans. I really hope that you have taken something from that video. If you find that you need to go over something again, or you need to write some notes down, please do watch the video again. Don't forget to subscribe, and please don't forget to check out my other videos on my Sound Science Physics channel. Take care.